Today we are going to cover section 3.1, complex numbers. So copy down your title, your essential question as well. How do you perform operations with complex numbers? Go ahead and copy or paste your cutout, pause it, and we'll continue once you are ready. So in this case, today we are going to cover complex numbers. And this is something that you covered last year as well. We have the following format, a plus bi. For a and b are going to be real numbers. And complex numbers are divided up in two parts, real numbers or non-real numbers. Now, real numbers is everything that you guys cover in Algebra 1. And if this looks familiar, it's because we also covered on the last chapter when we cover natural numbers, whole numbers, integers, rational numbers, and irrational. But now we have a different representation. And if you look at in your textbook, you'll see a little more colorful picture of it, where we have your real numbers and non-real numbers. Real numbers was everything that you cover in Algebra 1. And you learn that real numbers are made out of rational and irrational numbers. Now, do you remember the definition for irrational numbers? What is the definition for irrational number? What is an irrational number? Correct. So irrational number is any number that if you convert to a decimal, so for example, the square root of 2 per center gives me square root of 2. If I change it to a decimal, then it's going to give me a non-repeating decimal. Notice that the decimals do not repeat. That is a irrational number. We have square root of 13. So anything that is in a square root that cannot be simplified is considered an irrational number. If I change it to a decimal, the decimals don't repeat. Negative square root of 3, so the irrational numbers can be positive or negative. Pi, power 4. There's one more that we know. Do you remember another irrational number? Correct. E will be another one. 2.72. Now, rational numbers can be fractions, but when you change to a decimal, they are going to be repeating decimals. 11 over 7. If I change it to a decimal, notice that it kind of seems that they don't repeat, but if we pay close attention, after the 8, then we have 5, 7, 1. There will be 4, 2, 8, 5, 7, 1, 4, 2, 8, and so on. So therefore, this repeats, so that makes it into a rational number. Then within the rational number, we have integers. Within the integers, we have whole numbers. And within the whole numbers, we have natural numbers. So therefore, whole numbers are all the natural numbers plus 0. Integers are all the whole numbers, all the natural numbers, the whole number, which includes 0, and any of the negative numbers. Now, 5, it's also a real number, but it's also a complex number. And notice that in this case, if we think about 5, 5, it's a natural number, it's also a whole number, it's also an integer, it's also a rational number, it's also a real number, but it's also a complex number. And you might think, hold on, DS, it does not have an imaginary. So we're thinking about, and that's why they have this in here. We're thinking about the b being 0. So remember, complex numbers are real numbers and non-real numbers. 5 is a real complex number, where 3i is a non-real. Thank you. So 3i, it's a non-real complex number. So just be careful. So non-real numbers is anything that has an I. If it doesn't have, if only has the imaginary part, it's a pure imaginary. Notice that they give you the same definition, but now A is 0. So therefore we only have a I, which is a pure imaginary. And B cannot be 0, so we do have an I in there. Now, sometimes you might think, well, yes, when am I ever going to use this in life? Complex numbers are numbers that actually just came into play not too long ago, where, well, complex numbers are used in physics, engineering, number theory, geometry. And then in this article, they go through some of the mathematics of complex numbers, how we're working with complex solutions of a quadratic equation, the negative I, some of the math that we are going to cover today. Then they continue with some of the properties that we have with complex numbers. And then they start to expand into something that we call quaternions. Quaternions is not, we only have just a plus bi, but we also have a j and a k. So quaternions. And then we can continue learning some of the properties, some of the commutative properties, three-dimensional space. So whenever they are trying to position and orientate objects like spaceships, they use the quaternions. Or whenever they're using, trying to position cell phones in a three-dimensional world, they use the quaternions. But there's also something called octonions. And they go over some electromagnetic forces, some of the quantum physics. And that's when we realize. So, example number 1. Go ahead and copy it down, and then we'll start once you are ready. So let's classify, go and pause it if you need more time. But let's go and classify negative 3. Let's see, negative 3, and we're going to start with the smallest subset. Negative 3 is not a natural number, because it's negative. It's not a whole number, but it is an integer. So therefore, negative 3 is an integer. Negative 3 is also a rational number. Negative 3 is also a real number. And we're going to say it's a real complex number. So sometimes they'll place it in two sentences, so I can't see that. So they'll place it as a real number, and it's also a complex number. Sometimes they'll say a real complex number. How about E? So do the same thing for E and for 2i. See what you get, and then we'll continue once you're ready. Go and pause it. Excellent. So E, it's an irrational number. It's also a real number, and it's also a complex number. Or sometimes they'll say a real complex number. How about 2i? 2i is a pure imaginary number. Two I will also be a non-real number. And 2i will also be a complex number. So let's talk about complex numbers. So go and paste it or copy it. Example number 2, pause it, and then we'll continue once you are ready. So mathematicians create an expanded system of numbers using imaginary unit I in order to be able to deal with negative numbers that are inside the square root. And they define the square root of negative 1 as I. And this is the definition that you guys learned last year. where I squared is equal to -1. If we square both sides, so therefore if we have I is equal to the square root of -1, that's the one that you need to memorize. We know that if I square both sides, I'll end up with I squared equals the square root and the square root cancel, so that gives me -1. And that is the second definition that they have here. By adding real numbers to real multiples of this imaginary unit, the set of all complex numbers is obtained, where we have two parts. We have the real part and the imaginary part. And this is basically what we covered on the previous slide. If b is equal to 0, that means that that's a real number because the I disappears. If b is not equal to 0, then it's called an imaginary number. And if we just have a I where we no longer have the real part, that's called a pure imaginary number. Now let's go and perform some of the operations. We can add complex numbers and subtract them. And to add them is a very quick process. The book will actually just separate your real parts and then your imaginary parts and add them. For our purposes, we're just going to go ahead and straight add the real parts. That will give me 12. And I'm going to add my imaginary part, which gives me a -1i or just -i. Remember that you want to write down your real part first, then your imaginary part. We can also subtract them. So I can use my distributive property to multiply. So it gives me 3 plus 2i minus 5 plus 2i. And now I am going to add my real parts, and I'm going to add my imaginary parts. Now we added them, subtracted them. Now we're going to multiply. So copy example 3, A and B. Pause it, and we'll start once you are ready. So we are going to multiply a pure imaginary number with a complex number. So to multiply, we're just going to multiply. We're going to treat I as a variable. So therefore, 8i times 4 will give me 32i. 8i times -3i. 8 times -3 is -24. I times I will be I squared. And I know that I squared, according to the definition, equals -1. So therefore, that will give me 32i minus 24 times -1. Remember that those two are multiplying, so that will give me 32i plus 24. And whenever you write down your answer, you have to make sure that you write down your real part first plus your imaginary part. Letter B. Do you remember how to do this problem from Algebra 2? If you do, go ahead and pause it, and then we can check your answer. So in this case, we are multiplying two complex numbers. I'm going to, just like we multiply binomials, I'm going to treat I as a variable. So therefore, I'm going to distribute property. I'm going to distribute the 3. Then I'm going to distribute the -i. So 3 times 5 will give me 15. 3 times 4 will give me plus 12i. -i times 5 is -5i. And -i times 4 will give me -4i squared. And I'm going to do one step at a time. Some of you guys will start doing more than one step, which is fine. But for my purposes, I'm going to combine like terms, which will be the middle terms. You have 15 plus 7i. I know that I squared will be equal to -1. Therefore, I have -4 times -1. Most of the time, we'll skip that step and we'll say negative times a negative gives me a +4. I'm going to combine my like terms. That will give me 19 plus 7i, where I have my real part first and then my imaginary part. So try letters C and D and see what you get. Go and pause it, and we'll continue once you're ready. So at this point, you should have worked out both of them, right? And what did you realize? Did you notice anything? So in this case, we have, I'm going to use my distributive property to multiply the 2, then the 4, so it gives me 4 minus 8i plus 8i minus 16i squared. I'm going to combine my middle terms, and what happens? They cancel. So it gives me 0i, so therefore I squared is equal to negative 1 times the negative gives me a positive. It gives me 4 plus 16, which is 20. I'm going to do the same thing with letter D. I'm going to use my distributive property to multiply the 5. That gives me 25 plus 15i. Distributive property by multiplying the negative 3i. So negative 15i minus 9i squared. I'm going to combine my like terms, and what happens once again? They cancel out. 15 minus 15 is 0, I, so therefore that gives me 25. I squared is equal to negative 1 times the negative gives me a positive 9, so therefore that'll be 34. So if you notice, both complex numbers are almost the same, but one positive and one negative. In this case, it's one negative and one positive. Do you remember the name of this? They're conjugates. And whenever you multiply two conjugates, your answer will be a real number. And that will take us to the next definition. Complex conjugates. So complex conjugates have the form a plus bi in a minus bi. And whenever you multiply, the product is a real number, where the imaginary parts will cancel out. Go and paste it, copy it down, and example number 4, and we'll continue once you're ready. So in this case, we have added them, we subtract them, we multiply, and now we are going to divide. So write the quotient in standard form. So we have an imaginary part on the denominator, the same way that we can have a square root on the denominator. We don't want to leave an imaginary number on the denominator. So therefore, I'm going to multiply by the conjugate. This is 4 minus 2i. So therefore, to end up with a real number on the denominator, I'm going to multiply by the conjugate, so it'll be 4 plus 2y. Remember that you only change the imaginary part to the opposite. The force is the same. So therefore, this will be 4 plus 2y. And what you do on the denominator, we do on the numerator, so we can keep the equivalent fraction. And now we're going to do the same thing we did. We're going to multiply your numerator, multiply your denominator, and simplify. So let's go through our process. That gives me 8 plus 4i. So try to see what you get, and then we can compare our answers. Go and pause it. Got it? So it gives me plus 12i plus 6i squared. 4 times 4 is 16 plus 8i minus 8i minus 4i squared. Just like we talked about, the imaginary numbers will cancel out. Now I'm going to do this in one step. So that gives me a 16i. I know that I squared is equal to negative 1 times 6 will give me a negative 6. Do you agree? So a minus 6 will give me 2, and that's a positive 16. I'm going to do the same thing on my denominator. 16, this is I squared negative 1 times a 4 gives me a positive 4. So therefore 16 plus 4 will give me 20. And now I need to be able to separate. I can actually take the time to separate each one. So therefore it will be 2 divided by 20 plus 16I divided by 20. So therefore the 20 belongs to them both. And now I can reduce it. So it'll be 1 over 10 plus, reduce it by 4. So 4 over 5I. And notice that I place my I as a coefficient of the fraction. So try letter B. See what you get and we can compare our answers afterwards. Go ahead and pause it. So in this case, I'm going to multiply by the conjugate, which will be 1 plus 2i. I am going to multiply it out. Gives me 6 plus 12i minus 7i minus 14i squared. Multiply my denominator gives me 1 plus 2i minus 2i minus 4i squared. Once again, because I multiplied by the conjugate, my imaginary numbers are gone. And that was what we're trying to achieve. I'm going to combine my imaginary parts. That gives me 5i. So positive 5i. I squared is equal to negative 1 times the negative, we can say positive 14. 6 plus 14 will give me 20. Denominator, I squared is equal to negative 1 times the negative, we can say positive 4. Plus 1 will give me a 5. I can take the time to separate, but I'm just going to divide. 20 divided by 5 will give me 4. 5 divided by 5 will give me 1i, or just I. Make sure that you place your real part first and then your imaginary. Letter C. So therefore, what will I multiply to simplify that expression? So what should I multiply by? I should multiply by the conjugate, which should be positive 2i. Now if you multiply by negative 2i, it still works, but it might just take an extra step. So therefore, 3 times 2i will give me 6i, negative 10i squared. Denominator will give me a negative 4i squared. I'm going to simplify my denominator and actually simplify I squared is equal to negative times the negative 1 times the negative 10 gives me a positive 10. Let me write down my real part first, plus my imaginary, over I squared is equal to negative 1 times the negative gives me a positive 4. I'm going to reduce it by 2, so it gives me a 5 over 2 plus reduce it by 2 gives me 3 over 2 in my I. Let me not forget as a coefficient. And then if you need to write down as a decimal, we can, but in this case, this will be our preferred answer. So take the time to copy down your card and copy example number 5, and we'll start once you're ready. Go and pause it. So principal square root of a negative number. If a is a positive number, the principal square root of the negative number square of negative a is defined as follows. So whenever we have a negative inside a square root, we want to make sure that we simplify first. We take out that square root of negative 1, which is I. So therefore, the square root of negative a equals I square root of a. Do you agree? Perfect. So now when we simplify, square root of 14 of negative square root of negative 14 times square root of negative 2, we are very tempted to do the following. We are very tempted to say, well, I know before we've learned that we can multiply, for example, if I multiply square root of 2 times square root of 8, we've learned that we can actually multiply as 2 times 8, which is square root of 16, which is 4. Now, this rule only applies for real numbers. So therefore, we're not allowed to do this when we have a negative inside. We cannot say that this is equal to square root of negative 14 times negative 2, because that will give us square root of 28. So this is not valid. And I'm going to leave it here so we can actually compare it. So ideally, I need to go through a process and say, well, this is going to be square root of negative 1 times square root of 14. This is going to be square root of negative 1 times square root of 2. Square root of negative 1, I know is I. Square root of 14. Square root of negative 1 is I. Square root of 2. And yes, of course, most of the time we just skip this step, correct? And now I times I will be I squared. And because those are real numbers, we can actually take the time to multiply them, because that rule only applies when we have real numbers inside. That'll be square root of 28. The square I squared, we know that is a negative 1. So it'll be negative square root of 28. And we can simplify square root of 28. Which perfect square divides square root of 28? So square root of 28, we can do the factory, or at this level, you know, it should be square root of 4 times square root of 7. Square root of 4 is 2 square root of 7. So therefore, this will be negative 2 square root of 7. If you have done it this way, you have ended up with positive square root of 2 square root of 7, which is incorrect. So just be careful. Now, when we subtract, we're going to go through the same process. We are going to change this as square root of 27 will be 3 square root of 3, correct. I can rewrite square root of negative 1, square root of 9 times square root of 3. That is I, this is 3, this is 3. So we can write it down as 3I square root of 3. Do you agree? How about square root of 12? What will you get? Composite? Correct. Square root of 12 is square root of 4 times 3. The negative will become a 9. So square root of 4 will be 2 square root of 3. So you should be able to just do it automatically from here to here. But if you want, you can actually take the time to write it down as square root of negative 1 times the perfect square that divides 12 will be 4 and 3. That gives me I, 2 square root of 3, which went up with this. So therefore, we can subtract what's 3I square root of 3 minus 2I square root of 3. That will give me 1I square root of 3, or just I square root of 3. So we can treat this as if it was 3x minus 2x will give us 1x. And I don't need the coefficient, but you can have it there if you want. Letter C and D. Copy down, pause, and we'll continue. So in this case, I'm going to rewrite twice, but when I rewrite it, I'm going to change the square root of negative 5 as 5i. So it gives me a negative 2 plus, not 5i, but I square root of 5. And negative 2 plus I square root of 5. And now multiply it out, see what you get. Pause it. So that gives me distribute property for the negative 2. That will give me a negative 2I square root of 5 multiply. Oh, I already messed up, right? Did you guys see that? Yes. Well, let me just squeeze it on the front. Negative 2 times negative 2 is positive 4. Multiply that out. I'm going to multiply this out, distribute property, twice. That gives me a negative 2I square root of 5. And when I multiply this out, gives me I times I will be I squared. Square root of 5 times square root of 5 will be square root of 25, which is just 5. I'm going to combine like terms. And that should be I squared, correct? So therefore, that gives me a negative 4I square root of 5. I squared will be equal to negative 1 times 5 will give me a negative 5. 4 minus 5 will give me a negative 1. And just be careful. Letter D. Once again, before I divide, or before in one of the properties that we had before, if we did not have a negative inside the square root, so for example, if it was square root of 28 divided by square root of 3, one of the properties that we had before is that we actually can just simplify underneath one square root, and we can just say 28 divided by 3, which will be, oh, that's 24, which is 8. And then from there we can do 2 square root of 2. But this property only applies whenever they're real numbers, for real numbers. We cannot have a negative inside the square root. So therefore we need to go through the process of rewriting it as square root of 24. For now I'll leave it as I square root of 24 over I square root of 3. And now I can use the property where the i's cancel out. And now I can combine them into one. And I can simplify. And I can rewrite square root of 8 as 2 square root of 2. And I know you'll say, well, yes, you end up with the same thing. Yes, but the process here is correct. Where if you had done this process, that's wrong. Even though that answer is the same. And the last example for today, example number 6. Go ahead and copy it down and we'll start once you're ready. Go ahead and pause it. I to the power of 21. So we know the following definitions. We know that I is equal to the square root of negative 1. If you square both sides, then you know that I squared equals negative 1. And we're going to be using this definition to be able to simplify. So therefore, I need to think, okay, I squared. How many I squares do I have in 21? We have 10. 2 times 10 is 20. I need 21, so therefore I need one more. I know that I squared is negative 1. So what is negative 1 to the 10th power? And I still have my I. Negative 1 to the 10th power is positive 1. Times I gives me I, so therefore my answer is I. Let's go to the next one. I to the 35. So I need to think, okay, how many I squares do I have in 35? I have how many? 17. 2 times 17 is 34. I need one more, so therefore I need an I. That gives me the same. Do you agree? Now, I squared equals negative 1 to the 17th power. And I still have my I. So therefore my answer should have an I. Negative 1 to the 17th power, because this is odd, will be negative 1 times I we're going to rewrite it as negative I. So therefore, if you have an extra I, your answer should have an I. I to the 18th. How many I squares do I have in 18? 9. How many are left? None. 2 times 9 is 18. We know that I squared equals negative 1. Negative 1 to the 9th power will be negative 1. Letter D. On letter D, we're going to do it two different ways. Let's do it the normal way that we have done it. Do you remember what happens when you have a negative exponent? When you have a negative exponent, it goes on the denominator. Do you agree? Now I'm going to simplify. I want to simplify and say, well, I want to go through the same process. How many I squares do I have in 14? 7. Do you agree? 2 times 7 is 14. I squared equal to negative 1. So this becomes 1 over negative 1 to the 7th power. And what's negative 1 to the 7th power will be negative 1, which is negative 1. 1 divided by negative 1 is negative 1. Now, another way that we probably want to get used to doing it is as follows. And I'll do it on the left-hand side. I to the negative 14. I am going to go two more. I'm going to go over to the next integer. I'm going to multiply. I know that I squared equal to negative 1, correct? If I square it once again, I'm going to end up with I squared equal to I to the 4th power equals negative 1 times negative 1 gives me positive 1. So therefore, I'm going to be using this definition. So I'm going to multiply by a multiple of 4. So I'm going to multiply by I to the 16th power. Because we know that I to the 16th power will be 1. Do you agree? And if you multiply by 1, you end up with the same answer. So therefore, this gives me I to the 2nd power, which is equal to negative 1. So actually, I prefer if you do it this way. So let's see. Letter E. Or if you want, you can do it the longer way. I to the negative 21. What should I multiply by? I to the power of 24. Because if it's a multiple of 4, we know it's going to be 1. So if we multiply by 1, it's still the same value. So therefore, that will give you negative 21 and 24 will give you I to the 3rd power. And how many I squares do you have in I to the 3rd? Only 1. And then you have I. We know that I squared equal to negative 1 times I will give you negative I. Negative I to the 26. Oh, excuse me. 1 over negative I to the 26th power. So therefore, I am going to bring it to the numerator. So my negatives will stay there. No, remember, positive divided by negative is going to be negative. This will be I to the negative 26th power. Those two expressions are equal. Do you agree? Now, what should I multiply by? Which is the next multiple of 4? Will be I to the 28, correct? That gives me a negative I to the 2nd power. I know that I to the 2nd power is negative 1 times a negative gives me a positive 1. Make sure that you show me the work for each of the problems as you guys are working through your homework. Have a great day, and I'll see you guys next time.